Assalamualaikum and a very good day to all my students from the group D and group E. So we go into the part 1 from the chapter 6 about the analysis of structures. So there are, I think, more than one part of videos. It's very long videos, to be honest, right? So upon completion of this chapter, students should be able to understand and following the simple structure analysis. The first one, which is method of join, method of section, and then for the 6.2, which is about the frame and machines. Right, so there are two parts here. Right, so we go straight into 6.1 first, which is about the plate truss. Trusses are commonly used to support roofs. Okay, for a given truss geometry and load, how can you determine the force in the truss members and thus be able to select their size? So how to determine? So this is the thing that we need to consider, and then how we are going to minimize the cost. So you may read this general knowledge, okay, from your understanding. Alright, and then for the truss is considered as a structure composed of slender members connected together at their end point, or we call it as joint lah. So anything yang kita ada connected, so akan ada join. Okay, let's say kalau kita ada 3 point of truss and then kita ada join, so that's how it is look. Okay, so this is the frame, the example of the frame of the bridge. Okay, and then trusses are structures designed to support loads, will transmit loads through the joint of the structure, will ultimately transmit loads to the foundation. So this is example on the roof structure. So there are so many examples, so we go first into the roof structure, which is about the roof load, and then there are purlin, and then we have truss joint. So this is how it is look. Okay, I zoom a little bit here. Okay, so this is general knowledge how we need to transfer the load. So this is another example, which is about the bridge structure. From the deck load here, okay, and then we have a stringer, the long one, and then we have floor beam here. Okay, no, it's a straight line. Okay, if you see from the free body diagram on the side here, this is called the beam here. Okay, so how the example you may look here, how the bridge of truss joint load and the reaction force here. Right, so there are two reaction here, and then there is one reaction on the E. Okay, so how to determine whether it has X and Y axis? So yang tu later on kita akan tengok lah macam mana. Okay, so this is type of truss structure. Right, so there are so many types. You may refer on the slides from my Padlet. Okay, so some of you maybe not alert. I already put all the PDF file here in the Padlet, my Padlet. You may refer into the Google Classroom, right? So this is the exact figure on the pin support, roller support, and then rocker support. Okay, this is a joint connection. We have a welded connection, pin connection using a pin, and then gusset plate. So this is among the example. Working with trusses assumption, all loading are applied at the joint. Okay, yang ni you kena ingat. So semua loading applied dekat joint. Tu yang paling penting lah. Consists of entirely of two force member. So akan ada two force member lah yang connected into the joint, that one. Okay, all members are joining by pin connection. Right, so if there is any pin, so that's how the joint should be connected. So we have to differentiate properly on these three parts here. Okay, into the next part here, okay, which is we need to review two force member. a member or rigid body with only two forces acting on it. Normally this applied on a member or rigid body that has 2 points. For a two force member, the two force must have the same magnitude, same line of action and opposite sense. Right, so you may refer here which is T considered as tension, C considered as compression. Alright, so you may refer on this figure here. You can see the different on the F, A, B, and then the different which one considered as the axial tension and then axial compression. Right, so on the free body diagram for the truss, so we need to consider of 3 points here. The first one, which is overall free body diagram, we need to show the reaction force at the support here. So which support, sama ada dia rocker ke, pin ke, atau dia clamp memang together. Alright, so we need to differentiate lah, sama ada dia ada dua in terms of X and Y axis ataupun ada satu macam this one. So yang ni macam yang ni dia boleh bergerak on the X axis lah. Okay, so that's why dia cuma ada satu force on the Y. Okay, right, and then for the second one, which is from the free body diagram by members, we need to show the tension force on each force. And then free body diagram, the third one, which is force must be directed outward for blue force. Okay, so senang je. Kalau you all tak clear, kita akan go through by example. So this videos I think consists around the duration, which is around 15 minutes lah. So there are two parts. First, I need to make the videos. So there are two method of join, sama ada join ataupun join section. Right, okay, method of join, the first one, which is evaluate by the individual joint. Treat each joint as 2D particle. Assumption all members are in tension. Right, so kena ingat dia tension. Thus the force must be directed outward. Force dia mesti keluar lah. So tak ada yang masuk ke dalam daripada join tu. Okay, senang je. Kita akan go through first example first. Okay, ini you boleh tengok macam this one, which is the reaction. Right, so reaction dia kita boleh tengok lah. So that one, reaction dia mesti ke dalam lah, menekan ke arah support tu. So that's what we call as the reaction. Right, so this is the point C, and then point A you dah tengok that one. So yang ni given the load, which is 400 Newton. So bila kita nak carikan dia punya blue, mesti outward. So mesti keluar lah. So keluar daripada point tu, daripada joint. Okay, so this is the step for the analysis. So you need to remember at least these 3 steps here. The first one, which we need to draw overall free body diagram. You may refer to figure A here. Right, find the reaction force in terms of the Fx, Fy and moment. Ini paling basic lah. Okay, summation Fx, Fy and moment. Then the second one, draw free body diagram for each joint. So setiap joint tu, mana yang ada joint, you all kena lukis free body diagram. So macam dekat sini ada 4, so akan ada 4 lah. Okay, using equation equilibrium particle, find force. And then we need to start with only 2 unknown joint. Right, so yang mana kena ada 2 unknown lah in terms of that blue. So kalau sini ada 2, kita boleh consider sama ada C atau A, tapi kita akan ambil A lah. Okay, alright, senang je. So we go into the example 1 first. The truss pin is connected to at A and has roller at B. Right, determine the force in each member and state whether the member is in tension or compression. So kita kena determinekan lah each member. So dekat setiap joint tu kita kena consider. Right, so how to calculate the solution, sama ada di tension ataupun compression. So first step, we need to draw the overall free body diagram. Find the reaction force at the support. Okay, mana kita nak buat dulu? Yang ni kita memang dah tahu. Yang ni kita letaklah in terms of AY and AX. So ini figure dia, kalau boleh tengok kat sini lah. Okay. So macam this one, which is A dia, sepatutnya dia masuk ke dalam lah. You nak letak ke dalam boleh, keluar pun tak ada masalah reaction dia. Okay, tapi normally we put the reaction tu akan ke dalam lah, menekan kepada that joint. Right, so we go straight. First we need to find the moment from the point A. So macam ni kita nak kira the total moment which must equal to 0. So we need to consider of every forces that connected to the point A. Okay. So if we look at here, which is 4 kilonewton, so the distance here 1.5 tambah 1 meter, so dapatlah 2.5. So darab A ni, okay, darab 4 kilonewton ni kita akan dapat, which is counterclockwise. We consider counterclockwise as positive sebab tu dia jadi positif. Right, untuk second part pula, untuk 2 kilonewton ni darabkan 1. Sama juga dia ada tendency untuk counterclockwise sebab tu dia jadi positif. And then untuk last, yang ni dia jadi negatif lah sebab dia ada tendency untuk ke sana. Okay, ke arah clockwise. Boleh faham Saya rasa time ni saya sempat explain dalam kelas apa maksud tendency of the moment. Right. And then you need to find the total summation of force in terms of Fx. So bila Fx tu equals to 0 lah, tak ada force yang secara horizontal. Betul? So soalan tu tanya about the B. Force B ni kita tak tahulah kan berapa yang kita dapat. So that's why when we calculate, we will get the values of the force B which is straight. Right, so ingat B ni adalah roller. So roller dia boleh bergerak secara horizontal, x-axis. So dia cuma ada satu force je, which is force dia ke atas. So that's how you get the values of 24 kilonewton. And then bila kita nak calculate summation of Fx, why is it 0? Sebab kita dah setkan moment of A. So apa yang force AX ni kita tak assume lah, kita tak kira sebab moment tu dekat A. So ada tak yang horizontal lagi? Tak ada kan? So sebab tu dapat 0. I will explain more, okay, on the Fx and Fy. Macam tadi juga saya dah explain benda yang sama. Alright, kita assume naik atas tu positif, ke kanan tu positif. Right, like I mentioned previously, kalau dekat reaction punya support, dia better kalau ke dalam lah, menekan on that point. Okay. Tapi kalau you nak letak keluar pun tak ada masalah. Betul? Dia tak ada masalah. So bila you all calculate, pastikan positif atau negatif lah. Let's say kalau bila you buat macam ni, you akan dapat value dia negatif. So that's mean AY tu sepatutnya turun ke bawah. Okay, let's say kalau you dah determine awal-awal turun bawah tu positif, so bila you calculate you akan dapat positif terus. Okay, faham ya? Okay, clear kot on that part. So the second step, which is we need to draw free body diagram of each joint. Yang ni adalah joint dia lah. Okay, ni yang joint yang saya dah explain, yang mana every joint we need to make a free body diagram. So untuk this one kita akan go through on to the next part. Okay, saya rasa sebab tak sempat kot, kita tak boleh nak go through by long videos. So kita akan go through for the part 2.